In this lesson, we're going to look at density, and by the end of it, you should be able to determine the mass of a body, the volume a body occupies, and use the mass and the volume to determine the density, and use the relationship to be able to show that the unit for density is a derived unit. Alright, so what is mass? Now this information was stated for you in a previous lesson. But what was not mentioned was how do you go about measuring a mass. And you can measure mass by either using a triple beam balance, which is one that you will see in a laboratory experiment that you may have to do, or you may use an electronic balance. Either one of these can be used to find the mass of a body. But when you are measuring a mass, just remember to pay attention to this. You are using a balance. Alright? In both situations you are using a balance. Do not tell anybody that you measure a mass by using a scale. A scale is not used to measure a mass. A balance is used to measure a mass because we are balancing it against known values. Now, how do you determine the volume? The volume is the amount of three-dimensional space occupied by a substance or object. Hence, you will have the volume, capital V, being measured in cubic meters. In other words, 3 lengths. Another way to look at the volume is by simply having an area that is sweeping across a particular length. Let's say, for instance, you have a point and you sweep it. Notice you would get a line. Let's say if you take that line now and you sweep it across a given length again, you will get an area. From there, if you take that area and you sweep it across a particular length, notice that you will get a volume. So we can say that the volume is another way. A volume is another way of saying an area multiplied by a length, and this area here has to be uniform along the length that you're looking at. Alright, now notice m multiplied by m squared will give you m cubed. Alright, and most of the equations that you would find for regular shapes tend to do the same. Side cube, measure each side in meters, m cubed. L by b by h, length by breadth by height, and m by m means m cubed as well. When you look at 4/3 pi r cube, r is measured in meters, so therefore m to the third power is meters cubed. H is measured in meters, r is also measured in meters, but it is meters squared, so you'll have again m by m squared, m cubed. Alright, so that's the unit for volume. Now there are some volumes that are irregular. When it is possible, you can use the previous volume equations and compound them together to determine a volume that is seemingly irregular. But then there are some truly irregular ones where you would have to use one of the two methods below. And these two methods are used mostly in school experiments, introductory physics experiments. One is the displacement can, which is a can that has a spout attached to it. And what you're going to do is you're going to fill this up with water and allow it to overflow and allow it to stop flowing. And what it will mean is that the water level is directly on the spout. So when you take an irregular shaped object and attach it to a string and lower it into the displacement can, water will flow out into the measuring cylinder. And the amount of water that flows out into the measuring cylinder is equal to the volume that you actually submerge inside here. The next method that you can use is the measuring cylinder method. And what you would do is you take a measuring cylinder and you'd fill it with sufficient amount of water so that when an irregular shaped object is placed inside of it, it will be able to submerge easily. Once you do that, all you have to do is record this here, the initial volume, and then you simply submerge it and record the final volume. And the volume of the irregular shaped object will just simply be the final volume minus the initial volume. Once you're able to determine the mass and the volume, then you can determine the density, because the density is the amount of mass per unit volume of space occupied. Alright, just from this definition alone, you can see that you're taking mass and you're going to divide it by the volume. Now notice the unit of mass is kilograms. And notice the unit of volume, this is not supposed to be plus here, this is supposed to be, sorry, this is not supposed to be minus, it's supposed to be a plus, and it will be m cubed. Kilograms divided by m cubed, and I use my indice rules and I'll be able to get kilograms per cubic meter. Now you can use these as some reference information to go and search up some more, or You can simply message me with any questions that you have. Thank you.